What we're going to do today is functions, and we're going to start with the very basic part, functions, and that is just a relationship. So I'm gonna highlight. We have a relation which is a set of ordered pairs, and in that ordered pair, the first one is called the domain, and the second component is called the range. So the first thing we want to do is look at what's the domain and range of a certain relation. So if we're looking at this first problem, we have our domain as Smith, Johnson, Williams, Brown, Jones. So it's all the first components in this relationship. So the next thing is the range. Range happens to be the second component. In this case, it's the percentage. So we have 1.006. We have 0.810, 0.699, and 0.621, and then we have 0.621. Now the problem with our range is that we have two numbers that are identical. So what we want to do is only have one of them. So our range doesn't include this last 0.621 because we already have 0.621 as part of our answer. Now what we're going to talk about is what if a relation has a certain relationship between its inputs and outputs. It means there's a rule. And if that rule is applied and you only have one unique first component, we have what's called a function. So right here, a function is a relation in which two ordered pairs have the same first component and different second components. They have no two ordered pairs. So basically, if the first component does not repeat, we have a function. So if we look at our first component, and let me go back here, our first component, and we have 1, 2, 3, 4. They're all different, so this is a function. One corresponds to the next. Sometimes, and I want to highlight this part right here, we can show a relationship with circles, which is real easy to see if we have a function or not. So if we look right here, this is a function because all the names are different. But if we look at it the other way, and I want to highlight this one, let's say in green, this function, this is not a function because each function does not go with each name. The 0.621 repeats. So that brings me back down to my definition right here. So let's look at our next problem right here. We have 5, and we have 5 that repeat. As soon as we have a domain or an input that repeats, we do not have a function. So the whole definition of a function is understanding that the first component or the input needs to be different every single time.